Hi everyone, the topic of our project is the accident severity prediction with pre-clustering. The aim of our project is to build a classification model that accurately predicts whether a traffic accident will be severe or not, based on the geographical infrastructure, time and weather conditions at the time when the accident happens. As the label datasets are often expensive and time-consuming to generate, many semi-supervised learning methods have been proposed to learn from fewer labeled data points with the help of a large number of unlabeled points. Many of them adopt the cluster then classify technique. As illustrated in the figure here, this technique tries to increase the generalization of classification performance by placing the decision boundary through the sparse regions in presence of both labeled and unlabeled points. In our study, we perform k-means clustering on the labeled datasets and partition the unlabeled data into the clusters. Then we build separate classification models on each of them. We want to explore whether this technique would help us to improve our prediction model of the severity of accidents so that we can save a lot of human efforts by generating fewer labeled data points. For data pre-processing, we first clean the missing values by removing columns missing 10% of their data and delete the rows with no values for the rest of the columns. Secondly, we classify the attributes by different data type and employ different encoding methods. For datetime, binary, and Boolean attributes, we utilize one-hot encoding to convert them into numerical values. Attributes like states or counties have a lot of unique values, so we utilize frequency encoding where we use the occurrence frequency of an instance as its value. Special treatments were given to attributes like street names, wind directions, and weather conditions. We use methods from previous studies to simplify and generalize their categories. Finally, we use the Pearson correlation matrix to select 14 attributes from the original 49 attributes to build our model.
Next, we will apply the k-means clustering on the dataset. We will first find the optimal value of k, that is the number of clusters. We use the elbow method to plot a graph here. And it shows that the WSS reaches to a low level when k exceeds 3. And then we use another method called silhouette method. And it is a measurement of the separability of the dataset. And we will use k equals to 4, which has the highest silhouette value. And also notice here that the highest silhouette value is 0.48, indicating that this data set might not be as separable as we expected. And we will use the clustering label in two ways. The first one is we will add the clustering label as a new feature to the data set. And the second method is we will divide the original data set into 4 clusters and build a model for them separately. Next slide, please. So for the model fitting, we will first standardize the data set and use PCA to reduce dimensions. And we will build a logistic regression model for each subcluster and for the whole data set. And to predict an unknown data point, we will first use k-means.predict to predict the clustering label. And then we will use a corresponding logistic regression model to predict the target variable's severity.
So this is our preliminary results. We first apply the logistic regression model directly, and the accuracy for both train and test data is around 90%. Then we feed the dataset with the cluster label to the LR model. However, there is no significant improvement for this method. Therefore, we try the second method, which is predict within each cluster. We can see for cluster 2 and 3, the accuracy is lower compared to the direct LR model. However, the accuracy of cluster 1 and 4 increased to 95%. This might caused by the relative low silhouette value we discussed earlier, which indicate that our dataset is not really separable. So it's very important to explore the underlying structure of the original dataset before applying the cluster then classify method. But the overall result for the pre-cluster method is good. So in the following days, we plan to use cross-validation to tune our hyperparameters and also try other classification models like random forest, SVM, and KN to see whether we can further improve the accuracy. We also plan to apply more accuracy metrics so that we can have a better view of how well our model performs. For example, the false negative rate might be more important than the false positive for our dataset. So here's the reference, and thanks for listening.